talk about regression today, which is one of the concepts that comes up in each of the remaining units in Math 30-2. It's going to take a little bit of time to go through some of the terminology and procedures, and then you'll find with the remaining units it will go much faster. We use graphs in mathematics as a visual way to compare two different quantities. One type of graph is a scatter plot graph, represented here, where dots are used to compare those two different quantities. The line of best fit is the green line on my graph. You may have come across this in science. We're looking for what's the average distance between all of these dots, and then we can make some analyses based on that. So today we're going to focus specifically on a concept that's called regression. Regression is where instead of you manually figuring out where this line of best fit goes by hand, you're going to use technology, in this case your calculator, but a computer can also be used, that when you put the values in for the various points, your piece of technology is going to generate the equation of that line for you. Going back to grade 9, when we talked about interpolation and extrapolation, if you are interpolating the data, you're looking at, okay, here are the points that we know. Can we make an estimate when x is, let's say, this value? What will y be? So we can go up to that line and then figure out what would that y value be. Or likewise, we could say, okay, if y happens to be this, go over to the line, and then what would that x value be? What's our estimate? Extrapolation, and again the root words are kind of contained in here, is you're going beyond, it's extra. So let's say we have an x value out here. Well, that's beyond our graph, but we can predict if this line is going to continue that we're going to be somewhere up here and then move over and find the corresponding y value. We know independent data goes on the x-axis, dependent data goes on the y-axis. So the first thing we're going to do is figure out, given the problem that's presented to us, which is the independent, which is the dependent, and that's going to help us generate our graph. First thing you always want to do is identify the two things we're comparing. The units will sometimes give you a clue. In this particular example, we're comparing the mark that a student has with the number of absences that they have. The second thing you want to do is figure out which of those is your independent variable and which of those is your dependent variable, and just make a rough sketch so that you can visualize this. Be careful, because the independent variable is not necessarily in row 1. It's going to depend on the question. In this first example here, you're going to ask yourself, are the absences that you have dependent on the grade in that class, or could your grade be a result of your absences? And then we can identify that the absences are the independent variable, and then the grade you get is dependent somewhat on the number of absences. There is a correlation, generally speaking. Once we've figured that out, we're going to go over here to our sketch and we're going to say, okay, the independent variable always on the x-axis, in this case, is the number of absences. The dependent variable is the grade received in that course. I pulled my calculator into the screen so that we can see a little bit more clearly. I'm going to go through the example. I would encourage you to do this along with me so that you can learn how to actually go about performing a regression. The steps are listed in the notes, but we're going to just walk through and take a look at what happens. So the first thing we're going to do is we're going to go into the stat button, statistics. And we're going to go, number 1 is edit. That allows us to enter the data. So we're going to press enter. List 1 is always your independent data. List 2 is always your dependent data. So I'm going to go along and just type in these values. And so bear with me, it's going to take a minute here. So actually, you know what you could do is pause this video and you go and type these in while I'm talking here. Okay, so we have to go in order, and we're also going to make sure that we don't miss any. So we have a 7, a 5, a second 5, 4, 3, 2, 1, and then 2 students that have 0 absences. Take a look at your calculator screen. So you can see here, this tells us the line that we're on. So because I'm on line 16, I've entered 15 pieces of data. quickly count to make sure that you didn't miss anything, and if you didn't, then we are going to continue on. Okay, so now we're going to right arrow over to list 2, and we need to make sure that we put this in correctly. So a student who has 10 absences has a grade of 30. A student who has 12 absences has a grade of 35. A student with 10 absences has a grade of 50. A student with 8 absences also has a grade of 50. And then 55, we're going to carry on. 52. And we're just going to keep going here, typing in each of these values. And then every so often spot check to make sure that the right one corresponds. And when you get to the end, you should have them lined up. Once we have the data entered, we're going to go up to the top left of the calculator. We're going to press Y equals, and then we're going to arrow up to turn on the stat plot. So you want your cursor flashing. We're going to press enter. You should now see a black box on top. We're going to move across the calculator screen. We're going to go into window next, and we're going to set an appropriate window. So my number of absences along the x-axis, the minimum number is 0. The maximum number is 10. So I want to be a little bit lower than 0, and in this case I want to be able to see the y-axis. I want to be a little bit higher than 10, so I'm going to do 15. And then remember, scale is how often they put a tick mark. So in this case, every 1 unit is okay. My y-axis, my minimum value is 30. My maximum value is 99. So again, I want to be a little lower than my minimum, and I want to be a little higher than my maximum. Now, if I'm going on the y-axis from 25 to 100, I don't want a tick mark every 1 unit. That's going to be 75 tick marks. So choose an appropriate scale. 5, I'm going to pick in this case. We're going to go into graph just to take a look, and there is our scatter plot. So we can see as the number of absences increases, the grade tends to decrease. Once we've got the graph in there, we need to produce the line of best fit. In order to get that, we're going to go back to stat. We're going to right arrow over to the calculate menu. And you can see, starting at number 4, there's a variety of different regression types. We're going to go through most of them in this course. Today we're doing linear regression. So we're going to go down, and remember, this is your y equals mx plus b from when you learned linear functions in grade 10. We're using that a now to represent slope as opposed to the m, but it is the same equation. I'm going to choose number 4, and I'm going to press enter. Okay, so now we need to tell the calculator what to do. It's going to produce that linear regression using our data from list 1 and list 2. So if you look on here, above the number 1 button is list 1. To get to that, we're going to go second function 1, comma, right up here. Second function list 2, comma. And now to produce that line of best fit, we're going to go vars over to yvars, and then number 1 is function. That's what we want. Enter, enter, enter. There are differences between the TI-83 and TI-84 plus calculators. You start off the same way. Go to stat, edit, enter your data. Same thing, up to y equals, make sure your stat plot is on, set an appropriate window, and then when you go to do, you can even take a look at your graph, we've got the dots in there. When you go to get the regression line of best fit, we're going to go stat, same thing over to calculate, same thing number 4, and this is where it differs. Your calculator already has list 1 and list 2 entered. What you need to do is arrow down to where it says store regression equation. We're going to leave the frequency list blank. And once your cursor is here, now you do that vars variables over to y variables, enter, 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 and you're going to get the same values generated. So that's how you are going to go about getting your line of best fit. When you go into graph now, you can see that line is now in there. Going back to the notes in a second here, it says that we want to list that function to 3 decimal places. So a is going to be negative 4.988. Because this is a 0, I'm not going to bump that up. B is 90.339. Because my next number is a 2, I'm also not going to bump that up. Do not write what you see on the screen. Don't put y equals ax plus b, a equals this, b equals this. We're actually going to substitute those values into the appropriate place. Did all that work to get our line of best fit. We're going to now answer some questions. The first question we're asked is to use the equation, and you have to be careful because sometimes they'll ask for you the equation, sometimes they'll ask for the graph. They're going to be similar, but there are once in a while slight differences. In order to determine, in this case, we're looking for what is the grade given that they have 15 absences. This is why we want to always have a sketch with your axes labeled. We can see grade is the y variable. So in this case, we're looking for y when x happens to be 15. So we know x is 15. I'm going to take my equation that our calculator just generated. We're going to substitute 15 in the place for x, and we would predict, based on the data that we're given, that that student is likely to end up around 16%. The second question wants us to use now the graph to get that same information. So because we are, and again, you might want to make a note here. So we know x is 15, that represents the number of absences. We're looking for y, that is the grade. So to do this, we're going to go second function, trace, and then number 1 value is going to allow us to pick any value for x. So I want to put in when x is 15 and then enter. Y is going to be 15.519. So in this example, we happen to get the same thing using the equation and the graph. We won't always, so just be aware of that. So Y is going to be 15.519, which again is approximately that 16%. I'm going to skip down to D for a second, just because the last time my calculator actually stopped working when I switched into a different program. So I will put the notes up in a second here so you can see the whole question. But I just want to maybe do this one first. Okay, so if we're looking for y, so in this particular function, we are told that a student has a grade of 85. And again, we know that the grade is on the y-axis here. So in both of these examples, we are given y as 85, and we are looking for the value of x. So y is 85, and we don't know what x is. All right, so starting with D, the way that we do this is we're going to go into y equals, and there is our function. We're going to go down to y2, and we're going to enter 85. So this is going to give us a horizontal line. I'm going to press graph, and you need to watch the window. Sometimes the window might not be set high enough, in which case you'll have to adjust it. We now have two graphs intersecting. So to get that value of x, I'm going to go second function trace. Number 5 is intersect. I'm going to press, and then your calculator prompts you. So this is where the cursor currently is. You want to move it so that you're close to those two graphs crossing. Remember, don't go up and down because it's going to take you off the graph. Just use your left and right arrows. So we're going to scoot over here just so we're in the vicinity, and watch my cursor. As soon as I press enter, so it's asking, am I on the first curve? I press enter and see how it jumps? So the calculator is really good. You don't need to touch anything. So we're going to press enter to say yes again. And then it says, do you want me to guess the value? So we're going to press enter. And this is the coordinate point. So when y is 85, x is about 1.07. So it is, it is approximately 1.07. There is about 1 absence that we would expect that student to have. Back to C and D. In both of those cases, we're asked to find the number of absences for a student who has a grade of 85. If we scroll back here, we can see number of absences is on the x-axis. So in both of these, we're looking for the value of x when y is 85. I'm going to take my equation, and again, pay attention to what they're asking for. This is wanting us to use the equation. This is wanting us to use the graph. So if I'm going to use the equation, I'm just going to start with this. Y is 85, and then just algebraically solve for x, and you can see these two values are going to be very similar. Thanks for hanging in there. There's a lot of steps today, but when we do the next various examples of regression, it is going to get easier and easier. You'll become more familiar with the process. Take care, and I'll see you at the next video. few final pieces of information I want to leave you with. If you're doing a graphing question that is not regression, you need to turn off the stat plot. To do so, go back into y equals, go up to stat plot, press enter, and then arrow down, and that removes that black box. So anything that is not regression, you need to take it off. Anything that is regression, you need to turn it on. And the final piece of advice, when you have the data entered in stat and you want to get rid of this, you're going to go up to press the up arrow until you highlight the list, and then you're going to press clear and then enter. Move over to this one, go up and highlight the list, press clear, and then enter. Do not press delete. It deletes the entire column and it's not quite so simple to get it back. So always clear to get rid of that data.